Okay, so in this video, we have one more example of radical inequalities. We could graph both these guys, and we're going to do this algebraically. We're going to see what our solutions are. We want to know when this guy right here is less than this guy. So for what x values is that going to happen? We also have to worry about domain situations. So keep in mind we're going to solve algebraically. So the two things we always look at is the domain and then our algebraic solution. Okay, and using the graph helps tremendously with these types of problems. Okay, so we're going to solve algebraically, and we do that by squaring both sides. And what's nice with this one is they both have radicals, so the square cancels the radical out, and we're left with 9x plus 7 less than 14x. And we're going to go ahead and just solve it algebraically. So I'm going to go ahead and move the 14 over, so I'm going to subtract by 14x. And keep in mind that when we do that, I get a negative 5x plus 7 is less than 0, and then I'm going to subtract the 7 from both sides, and I get negative 5x is less than negative 7. And the one little thing that we need to be careful with is when we divide a negative, we switch or flip our inequality. So that means x is greater than 7/5. Okay? So when x is greater than 7/5, we should find some sort of solution here. Now we also have to work with the domain, and that's the other thing that we have to consider is what's going on with the domain. So we'll talk about the graph, we'll talk about the domain of our solution. So we want to look at the one that we're less than. So I'm going to look at this guy right here, and I'm going to put a generic graph of this guy, and there'll also be a video with the actual graph on our calculators in a subsequent video if you wanted to use that versus the hand-drawn one that I'm using. Okay, so we're going to do the domain here, and you'll see that I put a 2 here for my algebraic solution. Now when we consider our domain and also look at our algebraic solution, when I balance out my domain, it's going to be when x is greater than or equal to negative 7/9. So these are the only numbers that work for our square root function. Okay, so now let's look at this. X is these are going to give us real numbers, and notice the 7/5. The solution for this inequality is happening well after the negative 7/9. So this one's kind of hard. We really want to look at a graph to make sure we understand how to put our inequalities together. And so this is something where you would be able to use your graphing calculator. I'm going to put a generic graph up here because that's going to help speak to what our actual solution is. Okay, so the two functions that we have, so your y1, put the square root of 9x plus 7, and for the y2, put the square root of 14x. And I'll do this guy in blue, and I'll do this guy in red, and I'll draw a real quick graph here just to give us an idea as to what's happening, and I'll mark the solution. So the negative 7/9 is gonna be about right here, and this guy is going to kind of curve like this. Okay, very generic. Now our other guy, which is the square root of 14x, is going to go like this. Okay? And so I want to know when this guy is less than the 14x. So when is the red one less than the square root of 14x? Well, this guy right here This is our 7/5. That's our algebraic solution. So notice that the red graph is lower than the blue graph to the right of the 7/5. So this spot right here where our domain restriction is, it doesn't matter. We don't care about it because we're not even looking at that part of the graph. So in this problem, I don't have to include the domain because it's not a part of the inequality solution for this specific problem. So some of them, like the previous examples, we had to take that into account, but because of how this one worked out, all I care about is when the red graph's lower than the blue graph, and that only occurs when x is greater than 7/5. So I don't have to worry about the domain. So I'm saying, you got to look at the domain, you got to look at the algebraic solution and put them together, but you really need to also look at the graph to make sure that you're getting everything that is supposed to be a part of the actual solution. And when this problem is set up the way it works is all we care about is this piece right here. And because we don't have any negative values that we have to worry about, we don't even care about the domain in this problem.